All right, this last example kind of jumps back to chapter 7 in one way. It says this integral here cannot be integrated using elementary functions. And so what we can do though is we can find a Maclaurin series for it. I wrote find the Maclaurin polynomial, but let's find the Maclaurin series. Okay, so what we're going to do is first find the Maclaurin series for just e to the x squared, and then we can integrate that. Integrating a series is easy because it's just an infinite polynomial. So let's do this. E to the 2x is going to be, I'm sorry, not e to the 2x, e to the x squared. We're just going to take this and write x squared to the n over n factorial. And over here that's going to, we'll tell you what, let's go ahead and write this as x to the 2n. And our terms over here are going to be 1 plus, that's going to be x squared over 1 factorial, plus x to the 4th over 2 factorial, x to the 6th over 3 factorial, and so on. Okay, so now we can integrate this. And I'm going to do this by just putting a big integral sign in front of all this. So integral of e to the x squared dx is going to be, let's skip this part for right now. Let's go to these terms. So over here when we integrate, we're going to get a constant of integration. So I'm going to put that on the front. And then we're just going to integrate this term by term. So you integrate 1, you get x. Integrate this, you get x squared, or no, you get x cubed over 3 times 1 factorial plus x to the 5th over 5 times 2 factorial plus x to the 7th over 7 times 3 factorial plus etc. All right, so that's the integral of this thing. How can we write that in sigma notation? Well, let's see. We're going from 0 to infinity. Tell you what, I'm not going to try to cram it in there. I'm going to write it below. We're going from 0 to infinity. We've got to put that constant out front. And then we're going to come up with a formula for each of these guys over here. So let's look at it. This is, I'm going to write my n's on top. This is n equals 0, n equal 1, n equal 2, n equal 3, and so on. So if we look at this, the thing we have on top is x to the, they're odd numbers, so it should be something like 2n plus 1. Yeah, that gives it to us. Then down here we have 2n plus 1 for our coefficient. Then this is n factorial. So for our answer, we could write it as this, or we could write it as this. And that's it.